Hello, fellow explorers. Welcome back to Deep Dive, the podcast where we plunge into the depths of the unknown and surface with intriguing insights. I'm your host, Sally. Today, we're venturing into the vast expanse of space to tackle a question that's as old as our curiosity itself. Could Earth be shining like a beacon to alien civilizations? And if so, are they even noticing us, or could they be missing our signals entirely because they're looking for something else? Buckle up, because we're about to embark on a journey that spans from our own backyard to the far reaches of the galaxy. Let's start by exploring what makes Earth stand out in the cosmic crowd. Imagine you're an alien astronomer peering through a superpowered telescope. What would you notice about our pale blue dot? First off, Earth's atmosphere is a chemical anomaly. It's rich in oxygen, a reactive gas that shouldn't persist in large quantities without something constantly replenishing it. That something is life. But it gets better. Our atmosphere also contains methane, another gas that shouldn't coexist with oxygen for long because they react with each other. The continuous presence of both suggests active biological processes. Then there's the phenomenon of seasonal changes. The ebb and flow of plant life cause fluctuations in atmospheric gases like carbon dioxide. To an extraterrestrial observer, these predictable patterns could be a dead giveaway of a living planet. But perhaps one of the most glaring signs is our planet's night-side illumination. We've transformed the darkness with city lights so extensive that they create a luminous web across continents. This artificial glow is unlike any natural reflection and could be spotted by aliens with sensitive enough instruments. Let's not forget about our radio and television broadcasts. For over a century, we've been sending electromagnetic signals into space, unintentionally announcing our presence. While these signals weaken over vast distances, they have already reached numerous star systems. But there's more. Earth is enveloped by a swarm of satellites and space debris, a technosphere that could alter the way our planet reflects solar radiation or even create detectable anomalies in our gravitational field. And here's a kicker: we've introduced unique chemical compounds into our atmosphere, like chlorofluorocarbons, CFCs, and other pollutants, that don't occur naturally. These could serve as chemical fingerprints of an industrial civilization. Now, let's dive deeper. What other factors could make Earth stand out like a sore thumb, or perhaps a bright jewel, in the cosmos? Consider our use of nuclear technology. Nuclear explosions release not only massive amounts of energy but also unique neutrino signatures and gamma rays. These emissions could potentially be detected across interstellar distances by advanced alien sensors. Then there's the matter of megastructures. While we haven't built anything on the scale of the Dyson sphere, large-scale projects like the International Space Station or massive solar farms could alter the energy profile of Earth in detectable ways. Our planet also exhibits unusual electromagnetic activity due to our extensive use of electricity and wireless technologies. This could create a distinctive electromagnetic haze around Earth. Moreover, we've been experimenting with laser communications and could soon be using them for interplanetary messaging. High-powered lasers directed into space might catch the eye, or sensors, of an extraterrestrial observer. Now, here's the twist. What if alien civilizations are so advanced that they're not even looking for the kinds of signals we're sending out? While we're busy emitting radio waves, they might have progressed to communication methods that are beyond our current understanding. Take gravitational waves, for example. Detected for the first time in 2015, these ripples in spacetime are caused by massive cosmic events like merging black holes. An advanced civilization might harness gravitational waves for communication, encoding messages in the subtle distortions of spacetime itself. Or perhaps they're using neutrinos, tiny, nearly massless particles that can pass through almost anything without interaction. Neutrino communication would be impervious to interference that plagues electromagnetic signals. There's also the possibility of quantum communication, utilizing quantum entanglement to transmit information instantaneously across vast distances, a concept that defies our classical understanding of physics but is theoretically plausible. If aliens are using these advanced methods, our broadcasts might seem as primitive and undetectable to them as smoke signals would be to us. The flip side of this cosmic coin is equally intriguing. Could aliens be sending out signals that we're simply not equipped to detect? Imagine if their communications are embedded in the fabric of dark matter or utilize dimensions we can't perceive. Perhaps they communicate through modulation of stars, like intentionally causing slight fluctuations in a star's brightness to encode information. There's also the concept of astroengineering projects, like Dyson spheres or stellar-scale constructions, which could be the equivalent of interstellar billboards. If we're not looking for these megastructures or don't recognize them for what they are, we might be missing out on the most obvious signs of intelligent life. Moreover, if their signals are time-dependent, like messages sent over millennia, we might need to observe specific regions of space over extended periods to catch the communication. It's a humbling thought that we could be surrounded by messages and manifestations of alien intelligence but remain oblivious due to our technological and perceptual limitations. This leads us to the famous Fermi Paradox: if intelligent life is common in the universe, where is everybody? Perhaps the silence isn't due to a lack of extraterrestrial civilizations but because of a profound technological mismatch. We might be like ants trying to pick up Wi-Fi signals, it's simply beyond our capacity to detect. Alternatively, advanced civilizations might deliberately avoid contact, adhering to a kind of cosmic non-interference policy, much like our own prime directive from science fiction lore. There's also the possibility that civilizations tend to self-destruct before reaching a level where interstellar communication becomes feasible, a sobering thought that adds urgency to how we manage our own technological advancement. So, what can we do to bridge this potential gap? For starters, expanding our search methods is crucial. Projects like SETI are now incorporating searches for technosignatures beyond radio waves, including laser emissions and waste heat from megastructures. Advancements in gravitational wave astronomy and neutrino detectors might one day allow us to pick up communications we currently can't fathom. Collaboration across scientific disciplines, from astrophysics to quantum mechanics, could unveil new ways of perceiving the universe, potentially opening channels we didn't know existed. Most importantly, maintaining a sense of humility and openness to the unknown will drive the innovation needed to make that first, monumental contact. Earth is a remarkable planet, a vibrant oasis teeming with life and intelligence. We might very well be shining brightly in the galaxy, our signals echoing through the cosmos. Yet, the universe is vast and filled with mysteries. The possibility that we're both highly visible and utterly overlooked is a paradox that challenges our understanding and fuels our curiosity. Perhaps one day, we'll find that we're not alone, that someone, somewhere, has been listening all along. Until then, we'll keep searching, keep sending our messages into the void, and keep wondering about who might be on the other side. Thank you for joining me on this deep dive into the cosmic ocean. I'm Sally, and this has been another episode of Deep Dive. If you enjoyed our journey today, please subscribe to our channel, like this video, and share your thoughts in the comments section. Who knows? Maybe your idea will spark the next big discovery. Keep looking up, stay curious, and until next time, take care.